Look at this. To the untrained eye, it's a pile of dirt. But inside, it's a cathedral of climate control. It has ventilation shafts that outperform your office building, nurseries kept at precise temperatures, and structural integrity that can withstand a charging rhino. We like to think of ourselves as the masters of the earth, the only species capable of skyscrapers, dams, and complex HVAC systems. But we're late to the party. Millions of years before the first human blueprint was ever drawn, nature's architects were already solving the most complex engineering challenges on the planet using nothing but their bodies, their instincts, and the raw materials around them. Welcome back to Animal Lover Planet. Today, we are tearing down the walls and diving deep into the blueprints of the wild. We re-exploring how a creature with a brain the size of a grain of sand can build a structure that defies the laws of physics. Stick with us until the end, because we're going to reveal one animal builder whose work is so precise that NASA engineers are actually studying it to build colonies on Mars. You do not want to miss this. Why build? In the wild, energy is the ultimate currency. Every calorie spent building a home is a calorie not spent hunting or mating. So, for an animal to invest days, weeks, or even years into a structure, the payoff has to be life or death. The primary driver is protection. But it's not just protection from predators. It's protection from the elements. Take the sociable weaver bird of southern Africa. They build the largest nests of any bird species, massive apartment complexes that can house over 100 pairs of birds. These nests are engineered for thermal mass. During the scorching desert days, the central chambers stay cool. During the freezing nights, the collective body heat of the birds is trapped in the grass insulation, keeping the temperature up to 20 degrees warmer than the outside air. Then there's the spiderweb. This isn't just a trap. It's a masterpiece of material science. Pound for pound, spider silk is stronger than steel and tougher than Kevlar. But the engineering is in the tension. If one strand breaks, the entire web's geometry shifts to compensate, preventing a total collapse. It's a smart structure that communicates through vibration. These aren't just crude shelters. They are optimized, calibrated, and refined through millions of years of evolution. And as we move from nests to megastructures, the engineering only gets more mind-blowing. The termite mound, the heaviest specialists. Host. If you want to talk about true masters, we have to start with macro terms termites. They build mounds that can reach 30 feet high. But the termites don't actually live in the mound, they live underground. The mound is a giant lung. Through a process called thermosiphon ventilation, the termites use the sun's heat to drive airflow. The thin walls of the mound absorb heat, causing air inside to rise and exit through the top. This creates a vacuum that pulls fresh, oxygen-rich air through the porous base and deep into the subterranean nest. Animal Lover Planet fact. Even if the outside temperature fluctuates by 40 degrees, the internal temperature where they grow their fungus gardens stays within a 1-degree range. That is better than your Nest thermostat at home. The beaver, the landscape engineers. Next, we move to the only animal besides humans that can be seen from space because of its construction projects. The beaver. Beavers are ecosystem engineers. They don't just build a house, they create an entire wetland. They use a leaky dam design. By layering logs, stones, and mud, they create a barrier that slows down water but doesn't stop it entirely. Physics. This creates a deep pond that protects their lodge from predators like wolves. But look at the shape. Beavers often build dams with a convex curve facing upstream. This is the same principle used in the Hoover Dam. The curve redirects the massive pressure of the water into the banks of the river rather than the center of the dam. Weaver ants. In the tropical forests of Asia and Australia, weaver ants take engineering to an extreme level of cooperation. They don't use mud or sticks, they use living materials. To build a nest, dozens of ants form a living chain, pulling 2 leaves together with incredible force. But they have no glue, so they grab their own larvae, the babies, and gently squeeze them. This triggers the larvae to secrete a high-strength silk. The ants use their siblings as living glue sticks to stitch the canopy together. It is cooperative engineering at its most bizarre and brilliant. So how do they do it? No tools, no protractors, no CAD software. The secret lies in emergent behavior and stigmergy. These animals don't need a big picture plan. They follow simple local rules. If I see a hole, I fill it. If I feel a breeze, I block it. When thousands of individuals follow these rules, complex structures emerge naturally. Material science. Let's talk about natural adhesives. Swiftlets build nests entirely out of their own solidified saliva. It's so strong it can hold the weight of the bird and its chicks on a vertical cave wall. Mud dauber wasps mix their saliva with specific types of clay to create a ceramic-like substance that is nearly waterproof. The physics of capillary action. In many desert structures, animals utilize capillary action. By choosing specific soil grains, they can pull moisture from deep underground up into the walls of their structures, using evaporation to cool the interior. Human engineers have finally stopped looking down on animal builders and started taking notes. This is called biomimicry. Architect Mick Pierce designed the Eastgate Center in Harare, Zimbabwe, using the same ventilation principles as a termite mound. The building uses 90% less energy than a traditional building of its size because it breathes instead of using air conditioning. We've seen this with the Shinkansen bullet train, whose nose was redesigned based on a kingfisher's beak to prevent sonic booms. We're seeing it now with self-healing concrete inspired by the way coral reefs grow. The Mars connection. Remember that NASA tease? Scientists are looking at the honeybee's hexagon. The hexagonal honeycomb is the most mathematically efficient shape in the universe. It uses the least amount of material, wax, to hold the maximum amount of weight, honey. For space travel, where every gram of weight costs thousands of dollars, the honeycomb geometry is the gold standard for building lightweight, ultra-strong lunar bases. When we look at a beaver dam or a bird's nest, we aren't just looking at a pile of sticks. We are looking at a physical manifestation of instinct. These structures are more than just homes, they are extensions of the animals themselves. Richard Dawkins called this the extended phenotype. The dam is as much a part of the beaver's DNA as its fur or its teeth. But there's a deeper lesson here for all of us on Animal Lover Planet. These builders don't just take from the earth. They give back. Beaver dams filter water and prevent floods. Termite mounds enrich the soil with nutrients. Bird nests provide homes for insects and fungi long after the birds are gone. In our quest to build bigger and faster, perhaps we should look at these masters of slow engineering. Builders who use local materials create zero waste and improve their ecosystems rather than destroying them. Next time you're walking in the park or your backyard, look closer. That spider web in the corner or that bird's nest in the oak tree isn't just nature, it is a high-tech marvel millions of years in the making. If you found this deep dive into nature's architects fascinating, hit that like button. It helps our channel grow more than you know. Which animal architect surprised you the most? Is it the climate-controlled termites or the silk-weaving ants? Let me know in the comments below. And if you want to stay updated on the incredible wonders of the animal kingdom, make sure to subscribe to Animal Lover Planet and turn on those notifications. We have a massive video coming up next week about the hidden language of whales that you won't want to miss. I'm Bonnie, and thanks for watching. Keep exploring, keep learning, and keep loving our planet.